Hello! So in this video I am going to run through what you should know about scientific notation, or what is also called the standard form, and afterwards I'm going to run through what you should know about significant figures. So scientific notation is each time I have the number written as a number multiplied with 10 to the power of k, and this number needs to be between 1 and 10, and then k needs to be an integer. So it could be something like this, this, and that. And what I want to show is how I would translate this into a normal number, and vice versa. If I get a normal number, how I would translate this into a scientific notation written number. So if I were to translate this number, if I multiply a number by 10 to the power of 5, what I would do is I would move the decimal point 5 spaces to the right. So what I would do if I were doing this by hand, I would write 5, 7, 9, and then I would write a lot of zeros. And then I would say, okay, so if the decimal point starts off at the 5 spot here, and then it needs to jump 5 places, I would go 1, 2, 3, 4, 5, and then this would be the number. If I do the same thing here, what I would do if it's negative 6, then I need to move 6 places to the left. So in this case, what I'm going to do is I'm going to write a bunch of zeros in front, and then the 6, 2, 9, 1, which I have from these numbers, and then I do sort of like before, I just jump the other way. So I go like 1, 2, 3, 4, 5, 6. This is the spot where I put my decimal point, and then I don't need all of these extra zeros. If I have 10 to the power of 0, then what I would do, like before, I jumped 5 to the right, I jumped 6 to the left. This time I jump 0 spaces, so this time it's just going to be the number itself, because the decimal point moves 0 spaces either left or right. If I'm doing the opposite, if I'm given a normal number and I want to translate that into a scientific notation, what I want is I want the number to be between 1 and 10. So in this case, the number needs to be 2.79, like that. And then I need to say times 10 to the power of something. And then the question is, so what is that power? And then I sort of do the opposite of before. I count. So I say, if I were to move, this is like a decimal point. Then I would say 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore it's going to be to the power of 9. Like this. This number between 1 and 10 would be 5.8. And then this time it needs to be negative something, and in this case I would need to move 1, 2, 3, 4, 5, 6 spaces, so that would be to the power of negative 6. This 67, if I need to have a number between 1 and 10, it needs to be 6.7 times 10 to the power of something, and here I just move the decimal point 1 space, so it's just to the power of 1. So this is the way it works. I move the decimal point to the left if it's positive, so it's going to be a larger number, and to the right, opposite. To the right and to the left, if it's a small number, it's a negative number, it's going to be a small number. And opposite like that. Right. Then, for significant figures, if nothing else is stated in the IB system, then you're always due to give your answer to 3 significant figures. And therefore it's an important thing to know how significant figures work, so you can give your answers after all your hard work in the correct way. And the way it works is there are 4 rules. First rule is the easy one, that's just every number that's not 0 counts as significant. Rule number 2 is if I have these numbers and I have 0 in between, those also count. So these 2 zeros would count as significant because 2 and 5 are from this list. So this has 4 significant figures, this has 6 significant figures, and this number has 3 significant figures. And then we come to zeros that are not in between. Rule 3 is easy. Every 0 in front, so to the left of all the numbers, are 0. Another way of thinking about this is each time you have a number, we start counting significant figures at the first point where we get to a number that's not 0. So we go like, no, yes, this is the first number that's not 0. This is where I start counting. So this has only 1 significant figure. These two doesn't count, so this has 4 significant figures, this has 3 significant figures. Now, the fourth rule is the most technical one, and that is if it's zeros at the end, they only count if there is a decimal point. So because this has no decimal point, these 3 does not count, whereas these 2 does count because there is a decimal point somewhere in the number. Also, this 0 does count because there is a decimal point here. So as examples, this number would have 4 significant figures because these 2 zeros are trailing without a decimal point. This number would have 5 significant figures because we have these 3 zeros, but there is a decimal point. This would have 1 significant figure per rule 1. This would have 1 significant figure. This would have 1 significant figure because all the zeros in front doesn't count. This would have 3 because the 0 in the middle counts. This here would have 3. The 0 in front does not count. 2 zeros at the back does because there's a decimal point. This would have 4 because all the zeros at the back counts because there is a decimal point. This would have 1 because all the zeros in front never counts. If I'm given numbers in scientific notation, I just look at the number in front of the multiplied with 10 to the power of some integer. So this would be 3, 3, and 3 significant figures. I hope that helps. So have fun. Bye-bye.